So remember, quadratics are those U-shaped graphs, the parabolas. So we're going to be talking about, first today, just some of their major characteristics. So what can you see when you look at them on a graph, okay? So in this first section, they tell us that a quadratic function is typically written in this form. So just like our linear functions are always y equals mx plus b, these are always y equals a times x squared plus bx plus c, okay? While linear functions are a straight line, our quadratics make this U shape, like you see here, is what we call a parabola. So they want us to use this word bank over here to label all these pieces that the arrows are pointing at. All right, so the first thing that they have is a vertex. One of them's a maximum and minimum. So what does maximum mean? Outside of math, if I asked you what the maximum value was of something, what would that be? The most, right. So if I'm talking about the vertex and I'm talking about maximum, I'm talking about the highest, right? The most it could possibly be. So that would be this point right here on my graph. That's the highest that U shape goes, right? So this would be the vertex that we call the maximum. But if my U was flipped the other way around, while the arrows show that it would go up forever, this is the lowest point that it would go, right? So if it's flipped the other way around, it's still called a vertex, but instead of being a maximum vertex, it's a minimum vertex. Okay? All right, so we've taken care of those two. Next is what we call the axis of symmetry. Does anybody remember what symmetry means? Right, the same. Okay, so if I have an axis of symmetry or a line of symmetry, that means I can fold it in half on that line and everything's going to match up, right? Everything on one side is the same as the other side. So that would be our dotted line that we have right here. If I fold that U in half on that dotted line, everything's going to match up, right? Okay, so the dotted line here is what we call the axis of symmetry. Okay. All right, and then the last two are the ones you guys already know, an x-intercept and a y-intercept. So remember, an x-intercept means where it intercepts the x-axis. Which way does my x-axis run, horizontally or vertically? So on my horizontal line, those are the two places it touches, so both of those are what we would call an x-intercept. I'm going to abbreviate those to make it fit. Okay, and then a y-intercept is where it touches our y-axis, which is the one that runs vertically. So that would be like this point right here. So this is a y-intercept. Okay, so now that we know where to find all these pieces, it tells us that the vertex is a minimum when A is greater than 0. So greater than 0 means a positive number, right? But it's going to have a maximum when A is less than 0. So that would be all of my negative numbers. And what A is it talking about? This one right here. Whenever your number in front of the x squared is positive, you have a minimum. When it's negative, you've got a maximum. Okay? All right, so it says that the quadratic function f of x equals x squared plus 2x minus 8 is graphed below, and they want us to answer the following questions. So the first thing they ask is, where is the vertex? So what's my vertex again? Yeah, the bottom of the U or the top of the U, right? So that would be right here for us, right? So where is that coordinate point at? Negative 9 for the y value. What x value is it at? Looking for a coordinate. Yes, negative 1, negative 9. Good. Okay, so that point is at negative 1, negative 9. Then they asked, was this a maximum or a minimum? Well, it's all the way down here at the bottom, so would that mean a maximum or a minimum? Minimum, good. So this is a minimum. Okay, then it asked for my axis of symmetry. So remember, our axis of symmetry was that dotted line up there where we could fold everything in half, right? And if you notice, our axis of symmetry went right through the vertex, right? So ours is going to have to be the same. It's going to be a dotted line that goes through our vertex. So it'd look like this. If I fold in half on that line, everything's going to meet up, okay? So if I fold in half on the line, what line is that? The vertical line. So is that x equals or y equals? Okay, if I'm going up and I was supposed to be at y is -2, if I come up here, I'm not at -2 anymore, right? So it's x equals, what number am I at for x on that line?
0.
-1. All right. So this is the line x equals -1. So remember, it always runs the opposite way of its axis. Okay. Then it asks for the y-intercept. A y-intercept is where it touches the y-axis. Okay, this is our y-axis, it says. So it touches this line right here at this point. Where is that point? 0, -8. Okay, and then it wants the x-intercepts. That's where it touches the x-axis, right? So this is the x-axis running this way. How many times does it touch the x-axis? Twice. Touches it once right here and once right here. Where are those 2 points at? Very good. So -4, 0, and 2, 0 are my x-intercepts. All right, now we're going to talk domain and range. So we've talked about this before, but we're doing it for our linear functions, right? My domain, remember, is my x's, and my range is my y's. Okay, so x's, you guys said, were the horizontal line. Looks like my graph has arrows here at the top, and it's going to go like this, right, as it keeps going. So is it ever going to stop going to the left or the right? No. So if it's never going to stop, my domain is all real numbers. Remember, that's the capital R with the 2 lines. Okay, my range, that's my y values. Well, this thing has arrows going up, so is it ever going to stop going up? No. But does it go down forever? No. Where did it stop at? What was its lowest point? -9. So if I go up, do things get bigger or smaller? Bigger. So I would say y is bigger than the lowest point, -9. Okay, at -9, did I have a closed point or an open point? Closed. So I have to put the equal sign with it. Remember, it would be a point like this, where it's open in the middle, if I don't include it. Okay? All right, and then the last thing it asks us on this question is, for what values of x does f of x equal -5? Okay, so f of x is what we normally have where a y is, right? So they said when y equals -5, what is x? So I'm going to go over here to my graph and find y of -5. So there's my y at -5 right here on this line, right? So how many places does that touch my graph at? 2. Okay, so it touches once here and once here. What are the x values at those 2 places? And I think that's 1. 1 over from the, yeah. So -3 and 1. Good. So really not any solving to what we're doing here. We're just looking at our picture and pulling information. Okay, put your phone up, please. All right, same thing for the second one. It says, where is the maximum point? So remember, maximum point is, like Grayson said, the most, right? So this is our most. Where is that point at? And what's the x value at that point? 4. Very good. So this is at 4, 125. Okay, my line of symmetry, remember that's where we fold it in half and everything meets up and it has to go through our vertex. So remember, vertical lines are x or y equals, what we put on the front? X, X equals, what number were we at? Okay. Then it says the y-intercept is what? So y-intercept is where it touches the y-axis. Okay. Here's my y-axis. So this looks like where it touches that line. Where is that point at? Right. So the x value is 0. Y value 45. All right. Then it wants x-intercepts. That's where it touches the x-axis. Good. Okay. So x-axis is down here. How many places does it touch that line? Once at 9. Okay. So I have an x-intercept at 9, 0. I can't see it, but do I know that my graph comes down over here? Yeah. Right? And it's going to also end up touching the x-axis. If this one was at 9, that was 1, 2, 3, 4, 5 places away from the middle. So that one should also be 5 places away from the middle, right? So 1, 2, 3, 4, one more. One more from 0 would put me at -1. So I have another one at -1, 0. All right, and then we've got our domain and range. So remember we said domain is our x's or y's? X's, good. And x's go left and right. So my graph this time is coming down like this. Is it ever going to stop going to the left or right? No. Where? All right, it's kind of like the one on the front, right? It looks like this. And it keeps going, right? Past the edges, we just can't see it, right? Eventually our graph stops. So if it never stops, then our domain is not all real numbers, okay? All right, my range, that's my y's. Okay, so is this thing ever going to stop going down? No. But what's the highest we said it went? No. Right, that 125 we said is the highest this thing went, okay? So we said the highest is 125 and then it goes down. Do things get bigger or smaller when you go down? Smaller. So y is smaller than 125, and there's not a hole there, so it is going to have that equal to sign there. All right, and then the last question here is, what is the best estimate for the largest value of x for which this function equals 80? All right, so over here on my graph, here's 80, this line here. Okay, so what are the two the two x values there? 1 and 7, and it says they want the largest of those two. So the largest would be perfect. All right. Okay, we got one more here. Okay, this last one says it's the simplest quadratic function called the quadratic parent function, and it's this equation, y equals x squared. Make a table and graph your quadratic parent function. Okay, so whenever I pick points to plot, I want some that are over here and some that are over here, so it shows me most of my graph. So let's start with some negative values. Let's do -3. So if I plug -3 in for x, what's -3 squared? Close. -3 times -3 gives me +9. Good. Okay. And then we've got, let's do -2. What do I get when I square -2? So a negative times a negative is a positive. Okay, let's do -1. What's -1 squared? 1. All right, let's do the origin. 0 squared is 0. Okay, now we're going to do some positives. What's 1 squared? 1. What's 2 squared? And 3 squared? 9. Okay, so now we're going to plot these points so we can see what the graph looks like. So we got -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So there's our U-shaped parabola. All right. So the first thing it asks is, where is the vertex this time? Where's our vertex in this picture? Yeah. The point is at 0, 0. Okay, then they ask for the x-intercept. X-intercept means where it touches the x-axis. That's this line here. Where does it touch that line? 0. Okay, and then it also asks for the y-intercept. So that's where it touches the y, which is this line. Where does it touch that line? Also at 0. And then it wants to know the axis of symmetry. Where can I fold this thing in half? Yeah, down the middle. So that is at what value? 0. And remember, we always do x equals our number. Okay? All right, then the last two things it asks for is domain and range. So domain, is that x's or y's? X's. All right, so x's go left and right. I've got my arrows. Is this thing ever going to stop going left or right? No. So what do I put? Good. All right, and then my range, that's my y's. Is that graph ever going to stop going up? But does it go down forever? What was its lowest point? 0. Okay, so I go from 0 up. Do things get bigger or smaller? Bigger. So y is bigger than or equal to 0. All right.